So there's three basic image formats. Now there are many others, but there are three basic image formats that comprise about 95% of the images that are online. And so I want you to understand why we have image formats. Because when we have images like this one, what we have is a lot of information stored in one image. Now this square represents this piece of that image right here, blown up. So you can imagine that if we have three numbers times a million, that's a lot of information, right? Because there's easily a million pixels in this image, probably more. That's what megapixel means, in fact. If you say my camera is a 5 megapixel camera, that means every image that it takes has 5 million pixels in it. That's all it means. What is your iPhone's camera? Probably 14, 15 megapixels per image. That's why when you take a picture with your phone and you text it to somebody, I don't know if you've noticed this, it reduces the quality of the image. Why? Because the image has more information than you want to be sending. But it takes a higher quality image because you might want to use that for something. You might want to print it poster size for your wall or whatever. If you text somebody an image and then they take it and print it poster size on their wall, it's not going to look so good because it's been reduced. We'll talk about how to reduce image size in a minute. But first, I want to talk about image formats. The reason we have image formats is because in the early days of digital photography, the internet was painfully slow. So if I took a digital picture on my brand spanking new 1 megapixel camera, and I wanted to email you that picture of my cat or my grandkid or my foot or whatever, I could send it to you, and then it would clog up your email download for like 30 minutes while you waited to download this crappy picture of my cat. So somebody at some point said, hey, if this digital imagery is going to become a thing, and we're going to be putting images on our web pages and emailing them, doing all kinds of things, sending them over the internet, we've got to figure out how to take that image information and make it smaller, make it more efficient. Rather than representing all three numbers for every pixel in that image, we've got to figure out some mathematical formulas to reduce the file size of these images. And so in the beginning, there were really two image formats that were born. The first one that I want to talk about is GIF. Now, if you say GIF, I'm going to fail you in this class. I don't care about the arguments. What do you give at Christmas? Do you give GIFs to your family members? No, you do not. You give gifts to your family members. I don't care what the originator says. By the way, the originator says it's GIF, but he's a computer programmer, not a spelling champion. So let's just keep that in mind.
The guy who made it?
Yes. Yeah, that guy, yeah. So exactly. There's just no good argument for GIF. But that aside, also it's graphics interchange format, not graphics, right? So let's just calm down and focus on the thing at hand, which is, why do we have GIF? It was created, and the name implies graphics interchange format. It was meant to drastically reduce the file size. Now, GIF does do some other things. It gives us the ability to animate our images, which is the primary purpose why we use them now, right? For if we want to send a stupid animation to somebody over text, that's where we use it. That's how most of us understand GIF files. But they also have some transparency. Transparency is when you put the image on a different colored background and you can see the background through parts of the image. Now, GIF doesn't have really good looking transparency because each pixel in a GIF can either be fully opaque or fully transparent, nothing in between. So it leaves a very rough looking edge to any transparent parts of the image. It's not very aesthetically pleasing, but it's what we had way back in the 90s, okay? We're talking at least 30 years ago that this was invented. Okay, so that's a long time ago. Things have changed. We have better stuff now, but GIF does do transparency. The main thing that GIF does to reduce the file size is a process called indexing. Okay, and what it does is it says, I'm going to look at this image and I'm going to decide the 128 most common colors in this image. And you'd probably be like, yeah, that's easy, right? All I need is like red, green, black, maybe like dark red if I want to get really specific. You're the kind of person that doesn't know the difference between eggshell, white, and linen when you're painting your walls. Some of us do pay attention to that sort of thing. And if you're paying attention, this image of the red strawberry with the green leaves on the black background has millions of colors. So 128, really, it's not that many. If you pick a different image, like a picture of a rainbow, 128 is an absolute budget for that. Okay, if you have something that fades from one color to another, GIF doesn't do too good at that because the subtleties between those colors are what make that blend nice and smooth. You're going to end up with posterization, which is like bars of color instead. But what it does is it takes 128 of the most common colors in that image, and it says each one of you now gets one number. So I'm going to reduce the number of colors. I'm going to give each one of you a single number. So instead of 3 numbers that represent each color, I'm just going to, it's 1, 2, 3, and so on, all the way to 128. So now, what it does with those 128 colors, the most common 128 colors or approximations, is it says, now every pixel in that image has to be one of those 128 colors. And so each pixel now is 1, 1, 1, 1, 2, 2, you know, instead of 3 times the amount of information for each pixel, now we squish it down. So it still has the same number of pixels, but the images, the colors in that image have been reduced massively. The other thing that GIF does, and you wouldn't even know this unless you did some experimenting with it, is it does horizontal color striping. What does that mean? That means that if it has, let's say, 5 pixels in a row that are the same color, it won't say color 56, 56, 56, 56, 56, 56. It'll say you got 5 of 56. So again, shorthand, notation, less information. Same image, less information to describe it. So it's using that. Now, if I take an image that is horizontal stripes, black and white stripes of an image, and I compress it using GIF format, that image will compress very, very small. If I take the exact same image and rotate it 90 degrees so that those stripes are vertical, it will compress at a bigger size. Why? Because it can't use horizontal striping anymore. Very interesting. So what does GIF do well? GIF does animations. It's one of the few animated formats that has built-in animation. That's why we use it, that and the very small file size. Because we don't care if the little dancing baby that we send our friend is a really high quality, right? It's the thought that counts. So it does animations very well. It does cartoons very well. Why? Because Bart Simpson is basically 2 colors, black and yellow, right? So it does cartoons very well. It does logos very well because logos don't tend to have fading colors or anything. It's usually just a couple of colors on a simple background, lots of horizontal stripes. Perfect for GIF. So it does those things well. GIF absolutely sucks for photographs. Why? Because photographs have subtle variations. We're already, the minute we take a picture of something, and I don't know if you've experienced this, but you go outside sometimes in Bakersfield this time of year, and the sunsets are absolutely gorgeous, right? And you're like, man, I got to take a picture of this. You look at this gorgeous sunset, you take a picture of it, and you immediately look at your phone and you're like, that's not as great as the sunset. Why? Because the minute you digitize something, you're already taking the colors from like hundreds of millions down to just 14 million, which, oh, that sounds like it's still a lot, right? That's still pretty cool. But our experience tells us otherwise, that our eyes can see the difference between what we're looking at up here and what we're looking at once we hit it on our phone. So GIF is garbage for photographs because it takes something that's already not as good as real life and it makes it even worse. So what do we use for photographs? JPEG. JPEG, aside from not having a controversial name, which already makes me like it a little bit more, stands for Joint Photographic Experts Group. At the same time, or roughly the same time, they were working on graphics interchange format. A bunch of photographers got together and said, we can't do color indexing for photographs. We're already sacrificing too much. So we got to have a different formula for compressing the size while still keeping the quality. So what JPEG does is a process called interpolation. And what it does is it takes every fourth or fifth or 10th or 100th, depending on the quality, pixel, and it measures the color of that pixel. And then it measures the colors around that pixel. And it says all those pixels in that area, we're just going to average them out. We're just going to use one color for all of those pixels. And the more you compress a JPEG file, the bigger that averaged area becomes. So the lower the quality of the image becomes, but still better than GIF because the colors aren't limited. And it does do a pretty good job of averaging those out and interpolating those across the image so that you still keep some pretty good quality for a photograph. So JPEGs are great for images that are photos that have a ton of color. Okay, they're pretty good. Our iPhone native pictures, now iPhone puts a different extension on it other than JPG or JPEG, but guess what? Those are still JPEG files. It still uses JPEG compression. It's just a little bit more efficient for the iPhone, but it's based on JPEG. So for years and years and years, our iPhones took native JPEG files. Most cameras, most digital cameras, even high-end ones, shoot natively in JPEG or they shoot RAW. RAW just means they're capturing every single pixel at whatever the best it can do to approximate that color. And that's why the file sizes are massive, but you get the best quality if you're going to edit those images down later. Now, a little bit later in time, we said, man, we got GIF, we got JPEG. Those are pretty good, but the internet's faster now. We've gone from like really slow dial-up kind of speeds to the point where our phones are faster than the fastest internet connection was 5 years ago. We don't need to worry as much about file size. We still need to worry about it a little bit, but we're in the age of streaming video now. If I can live stream video from my phone over my connection, which, is 60 frames per second or 24 frames per second or whatever, then I can afford to send you a little bit nicer looking picture, right? I don't have to compress it so much. So we came up with Ping, Portable Network Graphics. It's got what we call a lossless compression algorithm, which means it gets compressed, but it doesn't lose quality. It's basically magic, okay? It uses a variety of intelligent algorithms to look at the photo and compress it without hurting the quality. Now, does it compress it as much as if it was a JPEG? No, it doesn't. But we don't care anymore as much because we have fast little internet connections all over the place. It also does something really cool, which is called alpha transparency. Now, all alpha transparency does is it adds one more number to each pixel. And that number goes from 0 to 100. And it represents how opaque or transparent each pixel is. A 0 would mean completely transparent. You can't see it at all. 50 means it's halfway transparent. So you can see it a little bit, but you can still see what's behind it. And 100 means it's totally opaque. So in this color channel, now we have an additional channel that determines transparency. And the nice thing about alpha transparency, as opposed to GIF's indexed transparency, is that with alpha transparency, you can fade something from, like if you have a gradient, you can fade from totally transparent to totally opaque in a smooth way, which allows your images to look way better on a background. So those are the three image formats that you kind of need to know about. It's important to know how they work, because if you crack open the data in a GIF file, you're going to see the color indexes, and you're limited to only using the colors in that index when you modify that file. A JPEG, you want to understand, is compressed using interpolation, which means the image data, when you start to edit it, you're limited as to what you do with that. And ping, of course, is a higher quality and has that alpha transparency. So each one has its own little set of capabilities and limitations.